Yeah. Sure. Yeah, why not? Can I call you back? Sorry, I've got a thing. Yep, I got in. Thanks a lot. See you later. Hi there, my name's Bruce Rain from Brackets Creations, and today we'll be reviewing the Kaiweets KM601 digital multimeter. If you haven't already, please like and subscribe. If you've seen any of my videos, you'll notice that I use a lot of different equipment, and I have links in the description for where you can buy that equipment. Ironically, I've never had a link to a digital multimeter, even though it's one of the most important tools in the kit. The truth is that I'm incredibly fussy about multimeters, and just about every one I've ever owned has had something about it that bothers me, so I haven't made any recommendations. The main multimeter I use today is a Fluke 115, and there's not much I can fault about it, but it's not cheap. Over $200 in fact. I like to give my viewers some budget alternatives, and this is why I'm taking a look at the KM601. Here are some of my multimeters. These days I generally only use two, the Fluke and this little Sanoir, because its size makes it really convenient if I'm doing some testing away from the workshop. Some of the issues I have with the other meters seem kind of trivial, but they can matter a lot. I had one with a push-button power switch and no auto power off. The button would regularly get bumped on and then I'd come back and find the battery flat. And that leads to another point. Most of these multimeters use 9-volt batteries, even the Fluke. And that's a bit of a pain too. We all have spare AA and AAA batteries lying around, but 9-volt batteries are rarely used these days, so I often have to make a special trip to grab a 9-volt battery for my multimeter. I have another multimeter with an auto power off feature that just doesn't seem to work some of the time. I go to test something and find the battery flat for no apparent reason. I've also had multimeters where I just haven't trusted the accuracy of the measurement, and that renders them pretty useless. So today we're going to have a good look at the Kaiweets KM601 and then put it through its paces. Okay, let's have a look inside. And oh, that's a really nice little case we have there. That's cute. And we've got the instruction manual, should it be required. Right. Oh, very nice, very nice. Like that. So here is the, oh, look at that. I see something that I already really like. I see AAA batteries, 2 sets of 3 AAA batteries. I'll be curious to know whether this actually takes all 6 of them. But I am a big fan of the AAA battery. So let's now have a look at this. Okay, very pretty, very pretty. It's got a nice sort of rugged case on it. It's nice, it looks good. So we're going to have to take that off to put the batteries in, so let's do that now. Alright, I see a little screw here. Let's get a screwdriver. Now, how does this come off? It comes from the top. There we go. And okay, so it just takes 3 batteries. So they've given us a spare set, which is really nice of them. I hope it doesn't mean it chews through batteries really quickly. I guess we'll find out. Okay. Let's pop those in. Oop, it just bipped. Alright, let's put that back. And then we will put that in there. And wowee, look at that. I tell you what, that big screen just takes your breath away. That's quite something else. And in colour, which is very nice. So yeah, that is really good. There are 4 holes in the bottom here for the leads. So you've got there your positive lead there, your common, and then you've got your MA and 10A there for your larger current testing, those ones there. And what have we got? We've got a little button on the side here. Oh, look at that. It's got a wee flashlight, or a torch as we call them here. That's nice. And on this side we've got the APO, or auto power off button. and that is indicated by this little icon there. If I press that, the auto power off is deactivated. Press it again, the auto power off is on. Now I happen to know from looking at the manual that the auto power off will switch this off if there is no button activity for 15 minutes. That in itself can be an issue sometimes, because you might be busily testing away but not actually pressing any buttons, and you could quite literally be in the middle of testing and have this switch itself off. But having said that, 15 minutes is a pretty decent amount of time, and I guess you can switch it off if you want, or you just have to remember to press a button every now and again to remind it that you are using it. Up on the top we have the power button, and pressing that for a couple of seconds will switch it off. Pressing it for a couple of seconds will switch it on. And then we have the NCV sensor here. That stands for Nissan Commercial Vehicles. No, it doesn't. It stands for non-contact voltage. So you can, or voltmeter, or non-contact is the important part of it, and that is that you can actually check voltage just through this sensor here, which we'll demonstrate in a little moment. Now, this is an automatic multimeter, and I need to talk about a couple of things to do with that. First of all, there is auto ranging. So I've got an old multimeter here, and with this one here, you actually have to select what range you want it to test in. So if I'm testing resistance, you've got to put in what is the sort of maximum, what is the maximum amount for that range that you're going to select here. So here we have like 2 kilo ohms, 20 kilo ohms, 200 kilo ohms, 2000 kilo ohms. But with more modern multimeters, they're auto ranging. So all you have to do is tell it you want to test a resistance, and it will automatically figure out the range based on what you're testing. This one takes it a step even further, and this one is completely auto, as they say up here, smart. And what that means is that it not only is auto ranging, it is also designed to detect what it is you're testing. So we're going to test this out. We're going to get some leads connected up first, and these are the leads here, and we'll have a quick look at those. And I quite like the tips of them. They're very, very pointy. That's good for doing fine testing. So we're just going to whip these little plugs out, and we're going to connect this up. Okay, so I am going to grab a battery here, and we're in the full auto mode, and I'm just going to put the negative on the negative there, and the positive on the positive there. Okay, so it has automatically figured out that I'm doing DC voltage testing, and that is showing us 3.685 volts there. Interestingly enough, it is also showing us the ambient temperature in the room here, which is 26.4 degrees Celsius. Quite warm, actually. So it not only is it auto ranging, it will also figure out what it is you're trying to test. If I grab a resistor and I go to test it, yeah, it's actually detected that I am in the continuity mode, and that's why it is beeping at the moment. It's designed so that if it's testing resistance and it's less than 50 ohms, it's going to assume you're testing for continuity. So this is a 27 ohm resistor, and so it has guessed that I am testing for continuity. Now, I personally don't like these full auto modes. I tend not to use them. I accept that they're probably handy for beginners, but for me, I would actually much prefer to specifically select which one I want to use. And there is a reason for that, and that is that when you are in the full auto mode, it has a delay. It needs a moment to actually go in and figure out what it is you're doing. So it looks at what you're testing, it analyzes it, and then it figures out, okay, well, this person's testing voltage, or this person is testing resistance. And there is a delay there. And in particular, when we're talking about this continuity mode, when you're testing continuity, you want that to be quite quick. If you think of this now, if I press this, 1, 2, It's like almost 3 seconds from the point that I touched it to when it actually gave me a beep. And that's not very practical if you're actually doing proper testing. So I don't necessarily see this auto mode as a fault, but it's just not something I use. And I'm sure it's something that other people do use, but for me, I would much rather actually going in and selecting continuity mode, and then there's, as you can see, it was much quicker then to give me that beep. But we'll do more on that a little bit later. Another cute little feature is that when you make a selection here for doing a measurement, it actually has little lights flashing here to show you which holes you should be connecting your leads to. So if we move this across here to MA, it's showing you they should be connected to those two. If I change it to 10A, it should be connected to those two. Move back here to the full auto, should be connected to those two. So it's just a very nifty little reminder. Now, one thing that KM601 doesn't have is the little click wheel, which is on a lot of multimeters. And sometimes on the really cheap multimeters, the click wheels can actually be really poor. Sometimes they don't have a nice, satisfying click into place, or they might be really easy to bump out of place by accident. Whereas this one here doesn't use a click wheel at all, uses the button to actually change selection. Unfortunately, if you press it too fast, it doesn't register them as each one as an individual click. So you do need about probably half a second's pause between each click. Once again, it's not a deal breaker or anything like that. It just takes a little bit of getting used to if you're used to using a click wheel like this. Next thing we're going to do is run this multimeter through a few tests, and we're going to be using this as a comparison. It's a Fluke 115. This is around about $220 US to buy new. These are Fluke are known for as a very good brand, good quality brand, and very accurate. So I'm just going to be comparing the results I get from the KM601 to the Fluke 115, and we'll see how it compares. So we're going to start off with some DC voltage. So I am going to connect them up to my bench power supply, and we're going to start off with 1 volt. And there we go, 0.996, 0.994, very, very close. Certainly that difference is not one that I would worry about. Let's try 6 volts. 6.013, 6.003, once again, extremely close there. Let's go up to 12 volts. Again, incredibly close there. And let's go all the way up as far as this one goes. This unit goes up to 32 volts. And once again, so in terms of the comparison in measurements there, it's extremely close. Now, I mentioned before that this is auto ranging, and you can actually see that auto ranging working down at the bottom here with this scale. This is showing where this is in relation to its scale. So I'll give you an example of that now. We'll take this down to, let's take it down to 9 volts. All right. Now you can see here that this is showing you in a scale of 0 to 10 volts. And so it is actually showing up there that it is just before that scale there that you've got 9 volts there. If I then tip this over to, say, 11 volts, you can see that goes right back again because we're now in a different scale. So that's that auto ranging aspect that I was telling you about. That is actually showing you that auto ranging at work. So in the first test, the KM601 does very well. DC voltage, the measurements seem to be very accurate. Now let's shove this thing in a power socket and try some AC voltage. So we're going to put that on AC. We're going to change this one from DC here, or I'll press the select button. Now we've got AC voltage. So let's start off with the Fluke. And we are getting 230.97896789. It's meant to be 240, so someone's robbing me of 10 volts today. But that's what we're getting there. So 230 around about, 230 and a half. And We're getting the same on the Kaiweets there, on the KM601, 230.8, 0.9. That's around about what we're getting there as well. Oh, we've already tipped over to 231 there. And if you have a look here, you can actually see the frequency as well of the AC voltage. It's actually showing me the frequency, 50 Hertz there. So that's kind of nifty there as well. Next up, we're going to do some resistance testing. So let's put this across onto resistance, and we'll get this across onto resistance. And let's grab ourselves a little 10 ohm resistor. Just move these across a little bit. Start off with the fluke. And we are reading 10 ohms, pretty much on the money. There we go, 10 ohms. Let's see what the KM601 says. And we've got 10, 9.9, 9.8. Still pretty close. $100 ohms. Okay, 99.9. 99, 100. There we go. Okay. $1,000 ohms. Okay, 0.993 kilo ohms. And 996.4 ohms. 100 kilo ohms. There we go, 99.5 kilo ohms. $99.4 kilo ohms. And let's finish with a 1 mega ohm. .946. 0.947. Now, allowing, of course, that these resistors may actually be a little bit out, a few percentage out from where they are meant to be. The main thing, of course, is making sure that these two multimeters are reading as close as possible. And the KM601 doesn't seem to have any issues with accuracy with resistance measurement. Let's just do a quick little diode test. So we'll put this into diode mode, and we will do the same here. Got my wee diode there. And we are getting 0.56768. And let's reverse that. And we are open, which is good. Now the KM601, come on. 0.602, 603. And open, good. Now let's try a little bit of capacitance testing. So I will change this to capacitance. I will do the same with this one. Start off with a little 10 microfarad. .4-ish. Okay, 10.07. Now you notice that took quite a while for it to come up with that reading, but once the reading was there, it's quite accurate. Now I've got myself here a 120 microfarad. And we got 121. Pretty good. You definitely have to hang around a while to get your result, but when the result comes, it is accurate. Let's try a nice big fat one. This is a 3300 microfarad. Okay, that one took a little bit longer on the fluke this time. We're reading 3518 for a 3300, 3488. Okay, that took a really long time. 3.385, 3.385, 3.391. Definitely a bit of a delay with the capacitance testing on the KM601, but still accurate. Another thing I'd like to test is continuity, and often when I'm working with old vintage computers like this, I have a lot of parts where I don't have any form of schematic, so I'm often having to do sort of reverse engineering, figuring out what goes where. And that's where continuity can become really, really important. So if I was to, just as an example, I'm just going to pop this into continuity. We'll do the same with this one here. I'm going to press and hold down for 2 seconds, takes me back to the beginning, and then I can go to that. All right, we'll start with the fluke. Just test it. There's the beep. Now, let's just say I am going to put this onto ground, and then I'm just going to scan this across the pins of the bottom to try and find all of the ground pins. So I slide it across. Oh, when I hear a beep, I go back. Okay, there's one. Oh, there's another. There's another. There's another. And that's quite good, so that worked out well. Now let's just try the same little test with the KM601. Slide it across. Okay, there's one, two, oh, another, and another. So there we go. So it is quite quick and responsive in getting those beeps out. And I have to admit, one of the things I do also really like about it, we just go back here, is a little green light which is up on the top of the KM601 there. The fluke doesn't have a light like that, so if you're someone with you know, sort of hearing issues, the little green light there is a nice little addition as well. Another thing that was included with this multimeter is a little thermometer. Little temperature probe there. We're going to test that now. We'll put this on to temperature. There we go. Put it into those two. Right, now here's my little probe there. It's showing there's Celsius, and that's Fahrenheit. It's 26 degrees Celsius here at the moment. Okay, so I've got a little container here of water with ice in it, and one here with some warmish water in it. So we'll pop it into the warmish water first. And as you can see, very, very quick to respond there, up to 40 degrees C. And then we'll drop it into the one with the ice. And we are down to 4 degrees C there. So that was very quick in changing the temperature, swapping the temperature between those two. So very, very responsive with its testing there. So that's another handy little feature. Another nifty little feature is the non-contact voltage detector, which allows you to find high voltages using the little sensor at the top of the unit. Handy for finding power cables in wall cavities. Now let's test the auto power off. 5 beeps as a warning it's about to shut down. Then 1 long beep before shutting down. Here is the Kaiweets website. We're just going to go across to the multimeters and we will go to the KM601, and if you have a look you'll see that their standard price on this is $55. At the moment they're selling it for $45.99, and in my opinion that price is incredible. When you consider what you get for that money, the number of features that this multimeter has, the bang for buck is absolutely incredible. There's a lot to like about the Kaiweets KM601. It's made well, it's nice and compact, about the size of a large cell phone, it's accurate, has lots of features, takes AAA batteries, is inexpensive and comes with a 3-year warranty. And that beautiful big colour screen is something else. It's a shame it doesn't have a stand built into the case like many other multimeters, and for someone who's been using a rotary function selector since forever, the push button has taken some getting used to. But this is real nitpicking. There's not much I can fault about it. I've really enjoyed using this meter and have absolutely no hesitation in recommending it. You'll find a link in the description if you'd like to buy one. Thanks to Kaiweets for sending me this unit for testing, and thank you for watching.